Next is about interpretation. So how to interpret the coefficients after we obtain the results. Let's say after we obtain this hazard function, okay, given covariates. So assuming here we have three covariates, x1, x2, and x3, and an intercept beta 0, along with beta 1 to beta 3 corresponding to the slopes for the three covariates respectively. And what we're going to do is here, I'm going to pick any random, excuse me, I'm going to pick a generic variable. Here is x2. Okay, so what I'm going to do is I'm going to increase x2 by 1 unit. Okay, so so here I increase x2 by 1 unit, and expression for hazard function becomes the exponential function of beta 0 plus x1 beta 1 plus x2 plus 1 beta 2 plus x3 beta 3. And next, what I'm going to do is I'm going to take a ratio of this hazard function after increasing x2 by 1 unit and the initial hazard function here. And after I carry out computation, the resultant quantity is the exponential function of beta 2. Okay? Having nothing to do with any x or any covariate in the equation. Thus, we can use the following explanation. That is, holding all other covariates constant for each unit increase in x2, okay? In your own work, including homework, what you're going to do is you're going to use the substantive unit, right? If x2 is education, then probably you're going to say, well, for each year increase in education. If x2 is age, you're going to say for each year increase in age. And if it is income, then probably you want to say for, you know, each $1,000 increase in income, right? Then the hazard rates vary by a factor of the exponential function of beta 2. And this is because we take a ratio, and that ratio is a constant. So this is what is called multiplicative change. Okay? And because we don't know if the exponential function of beta 2 is greater than 0, excuse me, is greater than 1 or smaller than 1. So we don't know if that factor change is increased or decreased. But to be more specific, if exponential function of beta 2 is greater than 1, then this is increase. So we're going to say, well, holding other covariates constant for each unit increasing x2, the hazard rates is going to increase by a factor of e raised to the power of beta 2 if that quantity is greater than 1. Otherwise, if that quantity is bound between 0 and 1, then we're going to say that's a decrease. So we're going to say, well, the hazard rate is going to decrease by a factor of e raised to the power of beta 2.